All right, welcome to today's webinar where we're going to talk about flows in action. I am Dustin Froyam. I am one of the co-founders of VirtualZ, and today I have Vince Ray, our CTO and co-founder, co-presenting with me. How you doing, Vince?
Oh, I'm great. Great to see you, Dusty. Looking forward to the call today.
All right, let's run through our agenda here pretty quickly. So we did introductions. This will be available for replay either on our YouTube channel or on our Skyward Data podcast, and that's available on any of the major podcasting networks. We'll talk a little bit about the problem with file movement and hybrid backups today. Then we'll dive into flows, talk about the architecture, some of the advantages of using flows. We'll do a demo as well that you can see flows in action from really install through moving data to a SAN environment, but can be a cloud environment as well. Do a little bit on use cases and deployment options. We'll talk pricing, and then we'll wrap it up with some Q&A and conclusion. All right, so let's just talk a little bit about the challenges with today's file movement and architectures from the mainframe and other backup scenarios. So legacy tools can kind of slow things down. Often there's multi-steps where you have to stage a file. You're kind of doing traditional ETL activities and which are multi-step. These can also be hard to maintain because you may have to have multiple products or some custom code in there that you also have to work with and maintain, or God forbid you're doing really costly and complex change data capture type scenarios, or even products that have that require an agent on the mainframe and on your target as well. So both the source and target components, which tends to eat into scalability because of a little bit lack of flexibility in those architectures. Can be disruptive to core applications, again, because of some of those ETL workflows that you'd have to do, and staging files may lock you into batch windows. Can't do it in your critical online window, things like that. And again, some of these fragmented architectures can get into the fragmented workflows as well. All right, Vince. So let's talk a little bit about why flows and why now. And so this product is really a plug and play product, out of the box, no code. All the code sits on the mainframe, and then you are able to go to hybrid targets or SAN on-prem or your private cloud or a public cloud. And you can do backups, file sharing, enable hybrid workflows as well through the file sharing. Eliminate that need for storage because it's kind of direct flow right out of your existing utilities and products on the mainframe side. And then you're really dealing with a single step, maybe two step in the most complex cases. And then you can provide that data for a lot of different purposes once you move it out. Okay, Vince, here's where I'm going to ask you to really talk about kind of our architecture and approach to the product overall. Could you just kind of walk us through that here briefly? And
Sure. Yeah. So I think you touched on a lot of the key points here. FlowZ is mainframe software. You install it on the ZOS. It runs as kind of a persistent service, started task, whatever you want to think of it as, and it creates, I think of them as endpoints, virtual files on ZOS that are bound to specific targets in the cloud. So this is a little different than what we do in, for instance, our ZAC product, where we create a virtual disk that acts and behaves like a normal mainframe disk. I mean, that's useful for a lot of use cases. But with FlowZ, what we're doing is creating a one-to-one relationship between something that looks and acts just like a file on ZOS and an endpoint somewhere else, in the cloud somewhere else. Now that endpoint in the cloud could be just about anything. It could be, I think in the demo we're going to see, we use, a SAN device with an NFS capability. We use that as an endpoint. We can support things like Google Cloud Platform. So if I've got object storage in the cloud that I want to write into or read from, I can do that. And honestly, one of the beauties of flows is that the output stage, where that data goes, is open. We supply a handful of them, and certainly if you have requirements, we can help you with that. But technically, it can go anywhere. It could be to an FTP site. It could be to a database. It could be really whatever you want to connect to can be done using Flow's kind of open-ended driver architecture. In fact, it doesn't really even have to be storage. It could be that instead of reading and writing records in cloud storage somewhere, it could be making API calls. So, you could directly populate data into anything with an API or query data from things with an API. Really, sky's the limit in terms of what we can connect to. So, back to the way this works. So once you have the Flow software installed and configured to talk to whatever target you want, you create, it looks like a Unix services pipe. It looks like a file system object. So you create an object that your ZOS applications can use to read and write data. But through your flows configuration, you say, I want that pipe connected to this driver with these parameters. So, Google Cloud Storage, this bucket, this file name, these attributes, all of that is specified in there. Once that's set up, then you can run just about any application and either write to that pipe, which is going to result in that data being stored in the cloud, or you can read from the pipe, which is how a mainframe application might read data from the cloud. So maybe you have I don't know, Workday or Salesforce.com or an application like that. You do a big extract of a big pile of data, store it in Amazon S3 or Google or wherever it happens to be in the cloud, and then you can read that data directly through flows just by setting up what I'm talking about. It's really convenient for the use case we're talking about. Things like backups. I want to take a disk backup, but I don't necessarily want to do that using a model that's based on virtual disk. If I do that on virtual disk or virtual tape, I have issues of how much data fits on the volume and volume switching, and all the normal ZOS stuff comes into play. With flows, none of that really exists. You can write as much data as you like into that file system endpoint. You write terabytes, and assuming your cloud provider is set up to allow you to do that, it's just going to be one big file. The other thing is, if your use case is really about data sharing, in other words, I need to write data that I'm going to read on maybe another platform or whatever those details are. Flows makes that drop dead simple. It's not like again, I'll just compare it to our ZAC product. If you were to look in the cloud at the physical storage we create in ZAC, it's a virtual disk image. So that means if I want to read that virtual disk from some other platform, I need to know something about mainframe disk formats and how data is stored on the tracks and all of that kind of stuff. With flows, not so much. It's just one big sequential file. If I need to write 100 files, I'd have 100 different files on the target, not one big virtual disk. So If the use cases are about sharing, it's much more straightforward to do what we do in flows. And some of you that know our products might also wonder how this fits in with our Propels product. I mean, Propels is a very similar case. Ultimately you're replicating mainframe data out to the cloud somewhere. Propels is mostly optimized where that data is going into a database, a JDBC database target where your data is going to live as rows and columns and all of those kinds of constructs. With flows, we don't care what that target is. It could just be a blob. It can just be a file. So if you have an application that just wants to do open, close, read, write, and access data that way, then flows would be your choice. If your application needs to do SQL, for instance, it's looking to do select a set of records and process them through SQL queries, then that's more of a Propel's use case. Certainly some overlap there. There's probably plenty of examples that work best both ways, but yeah, flows is definitely organized around that idea that it's a file on the mainframe and a file in the cloud, and flows kind of binds those two together, case by case, file by file. So Dusty, what did I forget or gloss over too quickly?
No, I think that's a good primer. Let's do the demo and then we dive into any other kind of follow-up items coming out of that.
Welcome to the VirtualZ FlowZ demo. FlowZ is a exciting new mainframe software product that we've developed, and what it does in a nutshell is it makes it very simple, very straightforward to get mainframe data to just about anywhere, whether cloud applications, network attached storage devices, just about anywhere. So we don't usually talk about the installation process, but I just wanted to spend a minute on that and show how simple it is. What you see is just a normal shell session on my mainframe. I have the FlowZ distribution, as you can see, and all it takes is a single pax command, to explode that archive. It runs, and you'll see a directory structure, such as on the video. This is the FlowZ product is pretty much ready to go like this, and as you saw, it can be installed literally in seconds. So when we talk about you can be productive, the same day you receive the package, we're not exaggerating. It's one of the easiest bits of mainframe software you'll ever deal with. Now, in the demo today, what we're going to look at is we're going to be sharing some mainframe data with a SAN environment, and in this case, I have a physical SAN device that's set up to be network accessible to my ZOS system. What we're looking at here is basically the control panel or the desktop that comes with the software. In this case, it's running right in my browser. And what I've done up to this point is I've just configured it to have an NFS link to my mainframe. So what I'm going to do now is I'm going to go into the various shared directories and I'm going to create a new one. I'm going to create a folder that I'm just going to call FlowZ. And of course it could be named anything. You could do this a lot of different ways. This is just one example. And of course we can support lots of things beyond SAN environments. And you'll see we're starting with a nice empty clean directory. Now back on my shell session, I'm going to do a little bit of setup work on ZOS. Probably the most important thing is I'm going to connect my mainframe to that folder that I just created. And this is done with a normal mount command. I can specify whatever file system name I want. That's just a logical name that ZOS is going to know this file system by. And as I mentioned, it's NFS. So I'm going to specify that. I'm going to specify that I want read-write access. I'm going to specify where it appears in the ZOS file system /mount/NFS. And that parm is everything needed to connect. So my IP address and the name of the folder we just created, volume1/shared/FlowZ. A lot of ways this could be done. This is just one example. You can automate this with FlowZ so that it happens under the covers every time a file is accessed. Totally up to you. Just showing this is kind of a simple way to understand what's going on here. So I've got my mount command, and I'm going to enter that command, and fraction of a second later it works. It's authenticated me. It's done all the things that our NAS device wants. And if there are any questions, I can use the display file systems command. And I see /mount/NFS has a file system called FlowZ mounted on it and some other statistics. So with the mount point created, now I can use FlowZ to create what I think of as a pipe, a local file system object on ZOS that's going to connect ZOS to that to that SAN resource that we just created. So I enter the command. You can see the output here. Nothing complicated. What I've done is specified the local name, the pipe file. That's the name that I'm going to reference the storage through. And I specified a target. In this case, it's a static target, but it doesn't have to be a static target. It could be a dynamic thing. Think almost like a GDG, that the name changes every time it's accessed. It might have the username, a date, whatever you need to be connected to it. And I see where it is, and I see that the creation of the object worked. If you ever have any doubt, we maintain the status of all of this. So, we see, FlowZ status will show us what we've created. If we've actually accessed data there yet, we would see byte counts and all of that. So I'm going to do a really simple thing. I'm back in a TSO session here, and I'm going to use some JCL to copy a little bit of mainframe data to that link I created. So I'm running, nothing even proprietary from us. I'm running the standard IBGen or IBM utility. My input is what you see, hello from ZOS, and the output is that object that I just created. So I submit this JCL. It runs nearly instantly. And now I've got data back on my SAN environment. Now let's go look at that. Back on the SAN desktop, I'm going to head back into the File Explorer here and see what we have. So again, this would look a little different depending on the kind of file you create. In this case, I open up, I'm still in that FlowZ shared file, and I see what we did. I see an 80-byte file called my file, and that's exactly the data that we sent to it with that JCL. You can see the properties, you can see the timestamps, security information, all of that is visible at this level. So, if I had another application, let's say running in the cloud that needed to reference this, that data is there for him, bit for bit. It's the same as what we put into the system with JCL in this case. Certainly, I could do it in a lot of ways. I could do it with command line functions. I could do all sorts of things. So, we've created I think of it as a trivial amount of data. Let's look at something maybe a little more complicated than that. What we're going to do now is we're going to create, same process. We're just going to create a different file. We're going to create something, and then we're going to take a system backup to this target. So I'm creating a pipe here called my NFS dump, and I'm mapping it to my dump on my SAN device. You can see the results, same thing that we looked at before, just different names. And now I've got that object. So I'm going to go back again to TSO, and in JCL, I'm going to run IBM's DFDSS dump restore utility. Now, to make this work best with FlowZ, there are a couple of small JCL changes we make. First of all, instead of running the normal program name, we change that to FLZ DSSU. It's basically just a small API example using DFDSS where we can load DFDSS and execute it through FlowZ, which allows us to capture the output and redirect where we want it. In this case, you'll notice I have a step lib. I mean, that's totally up to you. I mean, you know, as part of the install, you'll see how in the README file you would create this program. It's just running a link edit job. But the key is that I create a special DD statement, FlowZ dump, FLZ dump. And I point that, again, just like we saw with IEB Gener, I point that to the dump that I want to create in the network attached storage device in this case. Beyond that, it's just standard stock DFDSS. If I wanted to, I could write the dump in parallel both to a local file, you know, maybe I want to, I don't know, a virtual tape or whatever else, as well as in the SAN device. I absolutely could do that. In this case, I'm just using DD dummy because, frankly, we don't have the disk space to hold duplicate copies of the dump. But the control statements, we're taking a disk volume called B3 Res 1 that happens to be a 3390. We're going to take a full volume dump of it, and we're going to use the hardware compression feature on the system that I'm on. And again, all of the DFDSS control statements, everything about it is exactly the same. It's just that we ask you to change the program name so we can intercept some of the I/O that would normally go to tape or whatever it is. So I submitted that JCL. We can kind of watch it run. I mean, this is a 3390 disk volume, so it's in the order of a couple of gigabytes. We can see it running here. It's chugging along. It's doing its thing. We can see thousands of IOs per second being issued here. And, and we actually can look at the output and, just to confirm what I said before, you'll see the bottom half of the screen shows, just standard DFDSS. And that's it. It's done at this point. In our testing, we find that a 3390 disk volume can be dumped to our SAN device in about a minute and 20 seconds. If I look at the output here, I see exactly that. I see a minute and a minute and 24 seconds. So, and again, keep in mind our development environment is a very small, very, very limited system. If I toggle back to the SAN desktop, I see the dump that we just created. I see that it's 1.63 gigabytes written in the time that we were looking. And again, I want to be clear, we're running on a ZPDT system. That's basically ZOS running on an Intel hardware processor, a desktop PC. The SAN environment we have is a little baby thing that we do testing with. It's not like industrial grade anything here. So, we did dump that 1.63 gigabytes in about a minute. And, it is exactly what we expect it to be. I could do as many of these, as few of these as I want to. So, that's the quick version of the demo. You've seen, what we support in terms of targets. You've seen how to use it, how the installation works, and maybe even gotten a sense of the performance potential here. We look forward to hearing from any of you. If you have any questions at all, want to see different demos, have a technical conversation with us, by all means, don't hesitate to reach out. Thank you.
All right, Vince, thanks for that demo you recorded for us. Let's just talk a little bit about some of the use cases here. And I think we've covered quite a few of those in the kind of the lead up to this and the intro, and when we're talking about the architecture. I'll just kind of share a couple real world ones. So I know we have a customer that had done a data center modernization, and so they have gone to two primary data centers with IBM synchronous replication between those two data centers. But now they toggle back and forth in production. But now they have an issue that that data is completely synchronous. It's not air gapped. It's so if there's an issue that flows through their data or their systems, it's going to be persistent throughout both of those environments. And so one of the things that they want to do is have tertiary and quaternary backups that are geographically diverse, of course, and can easily be backed up or restored to those mainframe environments. However, they don't want to have the expense of a third or fourth data center, coupling facilities, more DASD, more VTL systems, and so they like FlowZ because that allows them to go to multiple locations, both private cloud, public cloud, with just a software solution and a very economical software solution at that. And so that's a perfect use case for FlowZ. Also, with the DORA regulations in the EU, similar backup type scenarios that are needing to be fulfilled, geographically diverse, separate kind of systems from your mainframe potentially, or at least that they're very geographically diverse or on different networks, those types of things, to create that security of that data in again a third or second, third or fourth site. And so again, FlowZ is a very, very easy implementation for that. Vince, any favorites of yours that you would share that are coming up?
Well, it's interesting to me. I mean, we actually use the some of the backup capabilities on our own system. I have an IBM Z PDT system here that runs our ZOS development environment, and it's on mainframe standard, it's quite small. It's about 3390 disk volumes defined to it. So, it's terabytes, but it's nothing as big as a lot of mainframes would be. I've always worried about hardening it and backing it up. And, many of the things I've tried have either just required so much disk space or been so slow that they've been really impractical. Nowadays I'm able to back up to, and I do actually two different things. I back up for high performance needs. I have small little $3,000 SAN environment connected to our PDT system, and that's just screaming fast. I mean, I can back up a 3390 volume in barely a minute. So half an hour, I can do a complete backup of our entire system. But I can also, on a regular basis, I can also go to. I mean, we just happen to use the Google Cloud for that. So I can, archive those backups to the Google Cloud. The cost is low. I don't have anything other than kind of consumer grade gigabit access to the internet, and yet it's not the kind of thing that takes a week to run. It's not as fast as going to my local SAN device, but it's still very practical, and it solves a specific need for us. So yeah, I think there are a lot of those use cases, and I think what's most interesting to me is from the idea of, gee, I should use our own product for this, to having it kind of deployed and done and scheduled and everything else. we're talking less than half an hour worth of work. So it's not the kind of thing that, and of course, that includes setting up the account at Google and provisioning it and defining everything you have to do in the cloud and, on and on and on that way. So, the fact that you can, have that instant gratification for what had been a hard problem is just, really eye-opening to me at least. So yeah, and I'm sure there are lots and lots of use cases out there. I mean, we hear new ones every day, it seems, every time we talk to a customer. Hey, can I use this to, replace a virtual tape library or, whatever the specific details are. And, we'll usually think about it. It's like, wow, yeah, you could use it that way. And, to me, that's a really good sign that we've done, a valuable thing here.
Yeah, like, Vince, I'm glad you brought up the kind of the ease of installation and setup. I mean, we see that in the demo, but I just wanted to kind of reiterate, is that really kind of the typical experience is, just a few minutes? And I think what you're saying is you're affirming that that is the case, right? From kind of install setup and to get started.
Yeah,
Um,
no, absolutely. And, usually you hear mainframe software and you think about, hours and hours or days and days or sometimes even weeks and weeks of work. And that's just not the case here. I mean, the install part is literally a couple of minutes if you have a modern system to install on. And I find where most of the work is generally going to be on the target side. What
yeah.
credentials do I need? How do I get a account set up? How do I configure my, I don't know, my storage bucket to have the class of service that I want and the cost attributes that I want and all of that stuff. That might take you a little bit, but honestly, in this day and age, I got to believe most mainframe sites have done that already for other platforms, so they probably know that stuff cold too.
Yeah.
So yeah, I think that's a really important point is that, you can be up and running and productive with products like Flows and, certainly the same day that you receive the materials from us. That's a really critical point.
All right, Vince, could you just walk us a little bit deeper into like data sharing and AI pipelines and how Flows kind of satisfies that? That was one of my other kind of use case questions I wanted to get into.
Yeah, I mean, a lot of times we see that many of the AI platforms out there are kind of built on this idea that they're going to ingest data. And a lot of times that's cloud data. You pointed to an Amazon bucket or whatever you happen to have. And again, that's a perfect target for flows. So, if you have that use case, then yeah, pushing the data in through using flows makes it really really trivial to get mainframe data into your AI system, which has always been I mean, at least the customers we speak to, that's always been a problem. People end up doing lots of custom code and APIs and restructuring of their data and on and on and on that way with flows. And by the way, not propels also. If your goal is to put that data in a relational database and be able to do SQL query against it, then propels is your answer. So yeah, that's super valuable and super productive, and you don't have to dedicate a lot of brain cells to figuring out how to get your mainframe data into your AI system that way.
Great. Um, we've talked a lot about the backup scenario. So yeah, this is just kind of going through what that looks like. We're completely cloud agnostic, no code on the cloud side. So that's a great architecture. Some other solutions for the mainframe in the market really do require, you know, software on both sides, your source and target, and get you locked into a single cloud where we can go to really any of those clouds very easily. So let's talk, I'll just share, we have some great partners you can work with they have offerings for on-premise as well as cloud storage architectures, particularly Polaire in this case. Also, Kyndryl is a great partner of ours in this area as well. Okay, I want to talk a little bit about the FlowZ pricing, and so the ease of use, the ease of implementation, and then the cost benefit here, and the time to value is very compelling. So we just charge, and this price is good through the end of 2025, $50,000 per year. This is an enterprise license. Oops, moved my slide forward there. This is an enterprise license, so you can use it across all of your implementations. It is personal to your enterprise, of course. So, but it should be able to satisfy all those use cases we've talked about, all the implementations. So no LPAR limits, MIPS limits, sites or location limits, anything like that. At $50,000, and again, that price is good through the end of 2025. So if that sounds interesting to you, please reach out to us, and we'll be glad to do a demo, some further demos, or you can trial the product at your site as well at no cost. And then, just when it's production ready, it's just the $50,000 per year. And you can lock in that $50,000 price on multi-year contracts as well. So if you're concerned about any price changes, we're very price conscious for our customers. So, the prices are going to go up a little bit in January, but so I'd encourage you to take advantage of the $50,000 for as many years as you think you might need it. Okay, I'm going to just Vince, you mentioned Propels, but really across our full stack of products, we can cover just about any data sharing, data access use case within the mainframe environment as well. So, we love to hear your challenges. We get some unique ones, and I don't think we've really come up with one where we can't do it. Sometimes there's a little bit of change or modification, but our goal is always to then really make that a GA feature of the product when we're done. So Propels is, as Vince mentioned, right, that's a very high performant direct access ETL tool where we can push that data to any JDBC target. There's also some other pipelines that go along with that for like your console messages into Splunk. So that's an available connector right into Splunk. That's real-time streaming of that data, SMF data, those types of things. Lozen is real-time read-write access, maintaining the mainframe as your system of record. And so application modernization. So you're migrating an application, but you don't want to have to go through a big complex data migration process. We've got some exciting news coming up on that one with some other partners that are building connectors into their code refactoring, code rewrite, code migration platform. So that keep your eyes open for that. And Lozen is also great for agentic AI. So if you want to, pull up real-time data into your AI agents, Lozen is the perfect solution for that, back to your mainframe data. And then Zach is the higher order storage solution for the mainframe. So this can run in virtual tape or virtual disk mode. So so it can fully replace DASD for certain use cases that you have, or your tape libraries. And so really FlowZ and Zach go hand in glove, and Propels and Lozen go kind of hand in glove in some of their use cases, but just on a higher order basis. All right, we've got a ton of resources for you available out there. So the blog, just a blog topics on just about everything. We've got thought papers, white papers, on just all kinds of topics around our products, as well as just mainframe data sharing in general. Each of these products have demos on demand, and you can find that right on our demos web page or our YouTube channel. Of course, you can try any of our products on an eval basis for no cost. And then I mentioned some of our social media and other outlets. So like again, Skyward Data podcast. So all of our webinars go into that podcast, as well as we've got other podcasts with just industry guests, really some interesting and awesome guests that join us for our Skyward Data podcast. All right. Thanks, Vince, for walking us through in detail some of the technology and use cases. And if you want to reach out to us, you can email us at hello@virtualzcomputing.com, or you can there's a web form submission right on our website, and we'd be glad to hear about you and your use case. All right, have a great day, everyone. Catch you on the next one.